Hi guys, welcome and thank you for joining my course, where you will learn how to create effective and efficient control systems to tell machines and software to do exactly what you want them to do. In this first lecture, we will look at systems and signals. Effectively, what are engineering systems and how do they interact with signals? So, what is an engineering system? An engineering system is any physical, mechanical, and/or electrical plant which can be driven by external forces or inputs. Essentially, this means that an engineering system is a machine that interacts with inputs to produce outputs and is well defined by a boundary at which these interactions occur. Let me give you some examples of engineering systems. These are machines such as cars, airplanes, robots, motors, computers, and so on. We are interested in these because their behavior changes with time. This is why they are called dynamical systems. For example, a car will move from point A to point B and spend a certain amount of fuel in the meantime while heating up in the process. These are all variables that we want to control. Examples of external forces or inputs can be impacts, friction, vibrations, wind or fluid loading, for example when you have internal pressure in a container, or electrical signals, and so on. These are also dependent on time and therefore result in dynamical systems. It is also very important for us to define what are systems boundaries. Systems need to be considered in the context of their environment. For example, an airplane flying at 11,000 meters of altitude will experience completely different loads from an airplane rolling on the ground. The former will have most of the loads concentrated on its wings, while the plane rolling on the ground will experience most of its loads on its wheels. So external forces act on systems at their boundaries with the environment. Going back to that plane example, the boundaries in this case are the fuselage and the wings of the plane when flying in the sky, and the wheels and still the fuselage when rolling on the floor. And it's at these boundaries that all the loads and external inputs are applied. In order to design effective and powerful control systems, we will use the systems approach. So how does this work? Effectively, we start from a physical system, also called an engineering system. We then use the well-known abstract laws of physics, such as statics, kinetics, electromagnetics, or hydraulics, to analyze that system and build differential equations that dictate how the systems work. This is the mathematical model of the system. If these equations are linear, and they have to be in that case, we can then apply Laplace transforms on these equations. Laplace transforms are mathematical methods which allow to simplify differential equations and make it a lot easier to solve them. They only work for linear systems, and they allow to find the transfer function between inputs and outputs. So from these Laplace transforms, we can then build and analyze a transfer function for the specific system we are studying and look and study the system response, or exactly how it behaves following different inputs. In order to transform you in experts at control systems designs, we will now study mathematical models of physical systems to then use Laplace transforms to transform these models into transfer functions and eventually build efficient and powerful control systems using control methods. This concludes this lecture on mechanical engineering systems, and if you have any questions, please do not hesitate to ask me. Thank you for listening, guys.